the invite to join, Simon, and I'm delighted to have an opportunity just to say a few words about Nesta and our sort of keen interest in the decarbonisation of the built environment. So just a few words on Nesta. Nesta we are a charitable foundation. We've been set up to basically support and promote, encourage innovation for public good. We've been doing this for about 20 years now, but under slightly different status and charitable foundation for the last 10. We've narrowed down the sort of areas that we want to focus on and try and have an effect on in partnership with others. But for setting ourselves some 2030 goals and basically narrowing down to 3 missions, and I'll touch on 2, but there's one that's most pertinent to this. One of the missions is really about trying to level up early years, trying to close as you can see, words on the slide, the outcome gap between the haves and the have-nots in the UK education system, particularly focusing on early years. We have a health mission, which is looking to narrow health inequalities with a primary focus for us around obesity, looking at food environments, food formulations, behavioural and biomedical interventions. And then most relevant to this conversation is our sustainability focus, which is really about trying to accelerate the decarbonisation of UK homes. And in that context, particularly looking at heating and energy as the main emitters of carbon in our domestic settings. Nesta sort of operates around these missions. We operate in 3 ways. We have a dedicated mission team set up under each of these 3 missions. And those teams are going into the value chains around each of the 3 missions, trying to form relationships with key stakeholders to start trialing things, being an innovation partner, to see what works and try and scale it, see what doesn't work and learn from it. But also looking at the sort of the policy environment, we call this system shaper. Where do we need more carrot or more stick to help innovation take root in and around these sectors? And starting to build up a policy capability, which I hope in time Pete and others will be able to tap into. And then the team that I work in is the venture building team. We have sort of 2 aspects to that. So we have and we're there in each case to underpin and back private sector organisations that are going to move the needle to a greater or lesser extent around the 3 mission outcomes. And we have 2 modes of operating, what we call the mission studio and what the team I sit in, which is Nesta Impact Investments. And the sort of subtle difference between these 2 is that the studio is actually trying to spin up ideas in the sort of white spaces around the missions. In truth, they're sort of grey spaces often, but sort of, are there innovations, be that product or service, that can help, accelerate the delivery of the outcomes that we care about. And then the team that I work in, where we write slightly larger checks and we deal with slightly later stage companies, where the sort of, the minimum viable product's built and there's probably early revenues, is slightly distinct. But one is right at the startup end of the scale, and then a business like Mixergy is really, is now in the sort of scale up and growth stage. So we hopefully can span quite a lot of the evolution of the businesses we back. Excuse this slide, it is a bit of a logo vomit. But we've been doing this for about 20 years, over 20 years, and under different guises with different strategies. I think the key thing for us is really the little line on this chart, which talks about 2021 and when we set these new missions. And you can see some logos on that chart, which includes Mixergy's, but a few others in and around the built environment. And let me just touch on those very quickly. We've backed a solar thermal business called Naked Energy, which we think can do, well, the COP on solar thermal is mind-blowing, but has issues. It's not necessarily an all-year-round solution, but we think the technology that Naked Energy have developed, and you can see an installation there that hasn't been announced yet, but the keen-eyed might be able to work out where it is. It is something that is absolutely vital. The COP is fantastic, and if we can find some interseasonal storage, then you've actually got a very interesting way of generating heat in the built environment. And then AirX is a much sort of smaller intervention, basically placing air bricks in properties that are always open, and just having a smart air brick that reads environmental conditions and open and closes depending on whether or not you need to ventilate or insulate. So a really simple measure, but a very effective sat point improvement, sort of cost-effective sat point improvement. And actually, like Mixergy, one of the few people to have Appendix Q certification, which maybe we can get into in due course. And then just a last few words, really. What we're always aiming to do at Nesta is do more than write a check. So writing the check, whilst it can be a painful process, is the easy bit of the process. Really what we want to do is try and leverage the capabilities and reach and networks of colleagues sitting in the mission teams to really sort of try and help the portfolio companies we back, but also sort of conversely see, the insights and the blockages and the things that have gone well for those portfolio companies to try and feed back into the work we're doing and helping shape the future of our work. So, it's a 250-person organisation. I work in a team of 10 in the investment side, but most of my colleagues are sitting in mission teams, one behind each, made up of multifaceted people: data scientists, project program managers, behavioral scientists, and really trying to get into the weeds of those the value chains. And then we do have a range of other skills and capabilities that we try to support our work with, not just investment work, but more broadly Nesta's work. So those are all the slides I really wanted to share on Nesta. I could whittle on for a long time, but really, in the context of this webinar, we came across and met, and I just want to say a few words on Mixergy, and forgive me, I'll stop sharing for a moment, because we saw Mixergy, the innovation that Peter, brought to how hot water is stored, generated and stored, and just really got very compelled by the position, the technology, but also the thinking that Peter displayed around the position of the hot water tank in the home of the future. And having looked at a lot of innovations in this space, we got really excited by the prospects of being able to invest in the business, and joined a round that closed. It was technically a Series B for anyone who's interested in the terms to these things, but a sort of roughly a 10 million funding round that completed in February this year, where we were lucky enough to join existing investors and a new investor, EDP, a big utility in Portugal, who also shared that vision for sort of the central positioning that Mixergy might have in a decarbonised home. So that is all I want to say as by way of introduction. But if it's all right, Simon, I was quite keen to, having the CEO and the founder of Mixergy on the call is always a delight. And I just wanted to ask Peter a few questions, if that's all right by you, Simon.
Oh, of course, please do.
Yeah, so Pete, I know a fair amount about the business, but I was just curious about your original motivations. What was it that when you were a student back in your days, and you're a young man, despite the fullness of your beard, what was it that really brought you to Mixergy? What's the sort of the creation story here?
Oh, wow. So, I think there were a few things which catalyzed the journey that we went on with Mixergy. So I remember vividly reading an article back in the early 2000s about fridges that responded to grid frequency as a way of absorbing surplus renewables. And that I found that a really cool idea. It was when I was an undergrad studying engineering in Edinburgh. I was on this bus, and I vividly remember reading this article and going, wow, that's cool. It wasn't until later, though, after I'd finished my undergraduate, I'd spent a couple of years working as an engineer, and then I went back to uni to do a PhD, and I was looking at energy storage technologies. I was kind of agnostic about what kind of energy storage. So looking at different battery chemistries, superconductors, giant flywheels, there's all sorts of different esoteric materials that could store energy. And at the time, my girlfriend and I had just moved into a small flat with one of these Economy 7 hot water tanks. Some of you may be familiar with the 2 heating elements. And it was running on a timer, which was not holding the correct time. So consequently, it's using a lot of peak electricity. At the same time, I was supposed to be going to the Maldives for my PhD, which was centered around getting the Maldives off diesel. and using things like storing desalinated water or creating ice stores for air conditioning plants as a way to allow them to put more solar onto their power network. Unfortunately, there's a coup, and so that kiboshed my PhD. But I was talking to my supervisor about hot water tanks, and that was kind of the starting point. Started testing hot water tanks to see if there's a way of controlling them to get them to work as demand response assets for the grid, meaning turning on and off when there's lots of plentiful cheap energy. And found actually, as we tested, there's lots you could do to enhance the underlying performance of the products. And that was, I think that was the starting blocks of it.
Fantastic. I might have heard some stories as well about you doing a little bit of Heath Robinson and re-engineering of solar panels as well, but that maybe was the as a keen technologist, never afraid to get your hands dirty.
Well, that was just briefly on that. That was because my job before was at before I started doing my PhD, I was working at Kinetic in the advanced propulsion department, working on hybrid electric drivetrains. And so then when I arrived at Oxford, started running the electric car club, and the objective of this competition called Shell Eco Marathon was to have a solar powered car. And so we developed a reconfigurable solar PV array. So rather than using power electronics, you have a load of individual solar cells connected to a giant bank of MOSFETs. And then you're changing the structure of the PV array, and you get rid of the power electronics. So an associated efficiency penalty. So it's kind of like if you had a car, rather than having a gearbox, you're choosing different engine sizes with the optimum torque characteristics for your truck. So it was a completely different subject, but yeah, that was quite fun and nonetheless.
Well, sort of maybe an interesting segue. It's about integration and it's about smart engineering, and that I think probably everyone on this call knows that we are in this sort of transition now in the built environment towards trying to get to a net zero basis for how we run our homes, and and I think certainly from our perspective, trying to find products and services that are easy to adopt and effective, and maybe have some sort of payback is critical. Tell us how Mixergy sort of fits into that transition in your mind, and how do you deliver sort of comfort and convenience and efficiency?
Yes, we've tried to fit into what I think is quite an uncertain landscape in terms of the trajectory that people's homes are taking to net zero. So a Mixergy hot water tank is developed to be agnostic about where the energy is coming from. So most of them will be installed at the moment with a gas boiler, but we have a couple of auxiliary ports which allow us to connect it to a heat pump in the future. If you get solar PV, you can bolt on a solar diverter module where the back of the immersion is. And so the idea is that it's kind of agnostic about which pathway the home takes as it decarbonizes. I think a lot of people, particularly at this point in time, are struggling with the economics of doing a whole house deep retrofit and everything that's entailed with installing a heat pump. And so we like to think of ourselves as a kind of gateway drug, swap out the hot water tank. It has, each system is also a connected node, so we run an embedded system which has quite powerful local compute capabilities, and also measures grid frequency and voltage. So the tank is delivering these services for the grid and the local distribution network potentially, but that can also extend its frontier control to other peripheral assets based upon local measurement within the home. And that's something we're doing right now with National Grid and British Gas with the tanks that we've got installed throughout the UK. So I guess I don't know how well I've answered your question, Alex, but yeah, we're trying to keep the net open with a product that's kind of accessible. We're not talking £7,500 home battery. We're talking £1,200 heat pump, something in the sort of mega flow end of the price spectrum. So premium but not outrageous.
Yeah. I think it does. I mean, being interoperable, I think our observations are there is no silver bullet, clearly. And, people on this webinar will know, we have a sort of quite an array of different types of property archetypes that have varying degrees of thermal efficiency, and so does a heat pump fit everything? We're not sure, but we know it is it's a very good solution. But I think certainly we've been taken by your interoperability, and you missed something there though, Pete, which was just the inherent efficiency of the tank itself. Which I think we were always saying.
It's actually not well known. So combi boilers are usually touted as an efficient option to go down and in replacing what would otherwise be a hot water tank. And that was true probably 20 years ago or more, where insulation standards in the intervening period improved so significantly. So even if you just take a standard modern unvented hot water cylinder, the heat losses are actually quite low. And the problem with a combi boiler is that whilst you don't have standing heat losses, you do get significant short cycling losses every time you turn a hot water tap on for a small period of time. You're having to heat up the flue, you're having to heat up the heat exchange equipment. It's not necessarily getting into condensing mode. Often it's not in particularly at hot water delivery temperatures. It's not in condensing mode if that's always what it's doing, only what it's doing. And so when you take all of that into account, the efficiency of an electric hot water tank, not ours, let's say a Megaflow, is around high 80s to 90% on a European draw cycle, which is used for the energy labelling product directive, as compared to something around 70% for an A-rated combi boiler. Now, what's interesting about that is an electric hot water tank gets a C rating. Why? Because the European-wide energy labelling directive assumes that all electricity going to hot water tanks first goes through a gas power plant, and then there's a conversion penalty, and then there's the grid, completely overlooking the fact that most of electricity in France comes from nuclear, overlooking the fact that a lot of people are getting solar PV. And we've been lobbying. We've published this paper with Oxford University doing experiments to do this test with incidentally a Megaflow tank and a Keston boiler. We published the paper. We sent it 2 years ago to the guys responsible for the energy labelling scheme. We haven't even had a response. So this is one of the challenges that we have.
That's not just a challenge with you guys as well. Is it the same for infrared? I think it's the same for infrared as well. I mean, as looking for alternative heating solutions in the house, and if you were to put in infrared panels, your EPC would actually worsen.
100%. Yeah,
it's bonkers.
It is. Yeah,
well,
yeah.
Probably
we can't figure out if it's cock up or conspiracy. It's hard, or just the latency of lots of big, parties trying to agree something and not the inevitable fudge, and then not wanting to reopen up, what might have been a few years of consultation and then negotiation. So yeah, it's frustrating, whatever it is.
Yeah. Sorry, Alex, go on.
Well, I was just going to say that touches on some of the, and you're touching there, Pete, on some of the challenges about the net zero transition. A sort of consistent policy framework or incentive framework certainly would rank quite highly. I mean, how do you see the challenges, in that transition?
Yeah, I think that there are huge challenges of a lack of coherence across many different dimensions of the policy world. So if you take energy markets, demand response, look at electricity systems. So we do frequency response for national grid. So that's a national service. When there's lots of energy relative to demand, the grid frequency drifts up, and vice versa. It comes down when there's a lot of demand relative to supply. So we provide this service with some tanks who elect to participate. Now, what's interesting with that, though, is that you also have distribution network operators who have different requirements for the national grid. They need to maintain the local voltage to within anything between 205, 207, I think it is, and 253 volts. That's the 230 volt nominal, 240 volt nominal, and then you've got this margin of error that you're allowed. Well, the problem is, as soon as you start putting EV chargers and heat pumps, and if you've got beast from the east and heat pumps are going to direct electric backup, voltage sinks. Now you can often have a situation where the frequency is high, So the grid wants you to turn on, but you know, Mrs. Miggins next door has a kettle on, you got your EV charger on. Actually, the DNO doesn't want you to blow the feeder transformer. There isn't as far as we can see, a coherent sort of policy direction to try and unify these different disparate kind of competing demands on the network. So you know, that's one problem. I could talk about, you know, the green home grants and some of our installer networks challenge being unable to claim against it, knowing only after the fact, and then just switching off. And I think you'll be very hard to get them interested in further stimulus from the government, because they've got enough work with swapping out combi boilers, and they've got a bad taste from a poorly administered scheme. So all under the umbrella of lack of coherence, I think.
Yeah. And do you see any supply issues, constraints, any, you know, certainly we're interested in the sort of the skills gap needed to decarbonize, you know, building stock at scale. You know, we are only just getting going on this journey, and as you've just alluded to, installers or heating engineers have got quite a lot of existing business, and you know, if you want to install something clean and green at the moment, you might be waiting 6 to 12 months to find someone who can come and do it. You know, do you see any constraints there, or is it how have you overcome those constraints?
Yeah, well, huge. So installers are short on supply. Getting hold of installers is a challenge. In terms of materials for the production of Mixergy tanks, we've been okay. It got quite scary at, you know, just in the aftermath of COVID. We had the, you know, famous electronic supply chain issues. We had to do quite a lot of work to keep continuity of supply. That seems to be abating now. I would say that, you know, on a macro level, you look at connections to new renewable schemes, you know, delays of 10 to 15 years to get a solar farm or a wind farm connected. Meanwhile, balancing costs have more than doubled in the last 2 years to just over 2 billion. And there's a pipeline of an additional equivalent to our existing capacity of wind that's now under construction, and yet we've got balancing costs doubling, and we haven't got really the prevalence of smart tariffs that would encourage people to absorb that to the extent that we would like. It's coming, but it could come faster.
Look, I think we're in total agreement there. And you look at, you know, likely electrical increase in demand for electricity and energy in our homes, you know, it's times 2 to 3, and we can't wait to increase the capacity of the grid by that.
Well, it's interesting, Alex, because in the last 20 years, demand's come down considerably. 30 years, it's come down. You know, although population has increased, people got bigger tellies. LED lighting, every heat pump. I don't think you can buy a tumble dryer now without buying a heat pump at the same time, because I think they all have to have heat recovery. So actually, a tumble dryer, I'd love to know if anyone knows this. I'm going to try and measure it one day, but I'd like to know if putting your washing on a clothes horse in your living room and drying it with your radiators, is that better or worse than a tumble dryer with heat recovery? Don't know. Maybe someone knows. I asked Miele, one of the manufacturers, but they haven't got back to me. But it's quite remarkable. So the grid's peak winter demand used to be 60 gigawatts back in like 2001, I think. It's now 40. So it's a big drop. But is it enough? Have we created? Because it's old, the network. You know, the average age of a transformer, I think, is something like 40 odd years old. So there's a bit of latent capacity, but is it enough to decarbonize? No, you know, as you say, it's like you've got to double, and you're between a rock and a hard place, because you could easily decarbonize a house by going to Argos and spending a few £100 on panel heaters, but then you triple peak demand. So that's the rock. The hard place is having to go into people's homes and rip them apart to put heat pumps in. And that's the hard place. But then you actually could potentially, if everyone had a heat pump, you could possibly stay within the constraints of the existing grid. Just maybe if you throw EV chargers on top. Ooh, I don't know.
No, but
Yeah, just bringing in here.
Sorry, Pete. I was going to say, so I think there's an opportunity. Maybe it's a Nesta investment, but there's an opportunity for grid balancing using EVs through bidirectional charging. So I have my Mixergy tank had one from April 21, fabulous product, air source heat pump, solar panels. We have EVs, but we only have a one directional EV charger. And every time I go around to places like Fully Charged Live and talk to investors, they keep saying it's coming. I think people like Indra are looking at developing them, but to me that's because I've got 100 kilowatt hours of batteries across 2 EVs in my garage, which would run my house even on the one day in the deep midwinter, or for 20 days in the summer when things are quiet. It needs the investment to get it going.
It's super interesting, Julian. So actually, we've asked this question of Centrica. What's their view of bidirectional charging? I've asked this question of some of the biggest housing developers, Barratt's, Persimmon, some of the big, because they're being forced through legislation to start installing EV chargers. They're only installing unidirectional chargers. I mean, there are a few forward-thinking developers like Zero Homes who I think might be looking at bidirectional chargers. The feedback we're getting, and I'm not sure I agree with it, is that it's unlikely to come at mass scale anytime soon. And I think the number of factors that they point to are, one, the battery warranty is the big one. So the OEM of the EV being reluctant there needs to be a tie-in with the utility or whoever it is that's flexing the battery and the degradation of its life, trading that off against the warranty. So there's like a commercial wrapper that needs to be developed. And there's also one thing that's been said that I recall is the difficulty in standardizing the design of the chargers across all the different markets, which have quite different electrical regulatory standards, and then just like the economy of scale of onboarding that with each EV.
Feels like, to be honest,
there's so much demand but when we go to Fully Charge and meet people like you, I think there's so much latent demand for it. And Nissan are doing it. I think Jaguar I-Pace can do it. Forgive me, Julian, it's not my domain.
My Honda E will do it.
Yeah.
So the tests at Octopus, I can't remember who the charger supplier was, and Nissan did a couple of years ago with their connector. There was no degradation in the battery. Nissan was perfectly happy with it.
Yeah.
You might take 3 or 4 kilowatt hours out of my battery. You're not taking fully draining it and then fully filling it back up again. So the actual the impact is very small.
Yeah. I also, Julian, actually, Western Power Distribution, DNO, they did a great study with EV chargers. It's called the Electric Nation. You can look it up, and they found that they reckon that they improved the life of the battery by having it bidirectional, because they're able to keep it at more closely to its optimal charge level. So like I say, I'm not sure I agree with the feedback of some of the big energy companies and developers. I think there's a groundswell of demand for it.
Developers are such a conservative with a small c lot. They probably think a hot water cylinder is advanced technology, and when they see yours, it looks like they think it's a Dalek or something. It's like, oh my God, we can't put that in people's houses.
I think that's right. Yeah.
Thankfully, you can, and people are. That's the important.
Oh no, it's a fabulous product. Yeah, as I say, I've had one for 2 years, so very good.
Cool. Yeah.
I mean, that just, for me, raises another little question, and it's fantastic that Julian's on the call as a Mixergy tank user. Sounds like an enthusiast as well. And, it is, at the moment, there is a scaling challenge, isn't there, about moving from those early adopters and the fully charged enthusiasts, of which we probably all are, and getting into the sort of the scale market and getting into to more end users' hands and homes. How are you going about that, Pete?
Yeah, so a number of different ways. One is, I think, by starting with a hot water tank, which is, as I said earlier, it's a nice glide path, because if you install it with a system gas boiler, you'll get better efficiency out of the gas boiler by avoiding short cycling. but it's also ready to either go just fully electric if you want to decommission the gas boiler and go for a really intensive fabric approach, almost to the point of a sort of passive house, or if you want to go down a heat pump route, you can put a plate heat exchanger bolt onto the cylinder, and it's ready to accommodate a heat pump. So try designing it in a way so that you're not front loading all the cost of decarbonizing that element of the system up front is one. And then secondly, trying to go through mainstream through regulation. So you mentioned earlier that we have BRE, Building Research Establishment, endorsement for SAP, Standard Assessment Protocol points for specifications in new build and social housing. Because some of the contracts are quite big, we've elected to start doing that under license with some partner manufacturers who are better equipped to handle those relationships, which helps with us achieving scale by attacking the market from multiple fronts. So yeah, I think those are the two primary prongs.
And then when you're licensing, then you're are you licensing the design of the tank or some of the hardware and the capabilities, because the interoperability isn't just generated through the hardware.
Yeah, so it's actually the full stack of hardware design changes to the product. So what we tend to do with a hot water tank manufacturer is try as much as possible to work off the base design. So we will ask them to move the heating coil for the boiler or the electric heating element to the top run, having it at the bottom. We can heat from the top down. We introduce a pump that's got an existing supply chain. So we're sort of tweaking the hardware within the scope of some of our IP that we've developed. We also have some embedded electronics that we supply them with, which they buy. So it's kind of a license plus a product supply dimension to it. And then, of course, there's the software which controls everything. And then you have the app through which you can provide a schedule or delegate control to the software that we have on our platform. So we're bringing that kind of wrapper with software and some tweaks to the design of their existing product line. So we're trying not to encumber manufacturers with tooling changes, intensive changes to their process. So there are more things that we're looking at doing to streamline it further. But that's the approach.
Thank you. And a lot in Nesta, we've been sort of pushing quite a lot about space heating and thinking about the blockers to sort of heat pump adoption and as one of the solutions. And also that the heat pump versus hydrogen debate. Let's not go there. But the sort of fabric first. Should we be spending a lot of time putting double glazing in every last window and making sure that our solid walls are properly insulated, cavity walls, etc. That we really spend the money on fabric. In that context, sort of why is innovation around hot water generation and storage sort of significant when we need to think about the fabric as well? So what is it about hot water that that creates that focus for Mixergy?
Well, for us, I think it's the merit order that you take with energy storage. It's if you're going to invest in 10 kilowatt hours of energy storage, either for your solar PV or for flexible tariffs like Octopus Agile and soon equivalents to come that we can see from the other suppliers. But you could get 10 kilowatt hours from a stack of lithium-ion batteries, home batteries. They're great, or for a few £100 on top of the cost of a regular hot water cylinder. It feels like a much more tractable first step. Where if in terms of the wider home, the latest product that we've launched is the integrated heat pump cylinder. So that's a small heat pump that goes on top of a hot water tank, and it's modular. So it's an existing product category, so you do have heat pumps integrated with cylinders. But the problem with the existing product category we find is that it's all just one homogeneous lump. So if there's a problem with a heat pump, you have to take the whole product away. And so you've gone from a 25-year stainless steel warranted tank to something that might only last 5 years, and it's also a bit of a nightmare to install because you got something like a 60-kilo top heavy thing to go upstairs. Now, so by making it modular, we're trying to solve those problems, but at the same time, a byproduct of the heat pump is cold air. So if you're concerned about the fabric, a big concern is you seal everything up and double glazing, and you get overheating in the summer. But with this product category for small, well-insulated properties, cool air becomes a byproduct. And so for our product roadmap, we see cooling, even in the UK, being for the residential sector quite a big frontier that's not often overlooked.
But also in the context, I suppose, of the rising build standards being imposed on house builders. Fingers crossed, we might just need a tea light to warm our homes in by 2030.
It's super interesting, Alex, because we've been seeing a lot of developers firsthand wrestling with how to interpret the latest version of SAP 10.2 and what recipe to go for. So one of the things that you'll hear them say is, oh, well, if we go for a fabric intensive approach, a row of 20 plots, suddenly you lose a plot on the end because just a small increase in insulation stacks up. So it seems like it's a kind of fudge between different measures. A lot of the big developers seem to be going down the monoblock air source heat pumps. Though if you go to the Salford Energy House, which I'd advise anyone who gets an opportunity to do so, it's really interesting when you see what the developers are looking at. So there's one of the homes has an in-roof heat pump, because of just the horror from their perspective in a small garden to be having a heat pump, with the noise colder, although they're quite quiet nowadays. So the other thing which we see, which is really interesting, is ventilation. You talked about the AirX brick in the beginning. Well, it's super interesting because it looks like they're moving more to sort of type 2, type 3 ventilation approaches, which means forced ventilation. Because of the tightness of the fabric, you now have to often have continuous ventilation as a rule. Of course, that's kind of dumb if you've only got one person and they're not cooking, so you've not got much in the way of VOCs or particulate to worry about. So you'd naturally then go down a path of air quality, ventilation control. So there's a lot of interesting things that are starting to emerge, which you can see at places like the Salford Energy House with respect to new build. At the end of the day, it's still a culture of lowest cost of compliance, unfortunately. So it's, I kind of feel like if they just reconfigured the way that new builds is incentivized, you could stop the cat and mouse between BRE, SAP, and value engineers who are looking at the first opportunity to knock off a couple of solar panels or, use a bit less insulation. And I kind of feel like with smart meters, you could do something by connecting like fleet average energy consumption to corporate tax. So if you could actually incentivize them to, hit their bottom line with, as a carrot, you'd transform. So, and there's a lot of really smart value people who spend all their time doing optimization in new builds. Imagine if they were aligned to try the problem rather than keep SAP as a minimum standard, but why not encourage them to go way further? It's I don't know. There's probably a bunch of reasons why.
I mean, we have a lot of developers on, and the smaller guys are obviously more nimble. And because we invite them on here, we're talking to people who are already doing way over and above the minimum standards, etc. And over time, the gap between the regs and getting to passive house is going to get smaller and smaller, and then the major house builders eventually over time are going to be effectively building equivalent of house. But I mean, the new build space is almost like an easy challenge to solve because of all of those things you've just mentioned. The problem is retrofit. And did you you introduced a small tank now that lives in that makes it easier have smaller hot water tanks in flats. Was that you guys?
So we do have we go down to sort of very small 90-litre slimline tanks, which are good for flats, good for getting through. You find a lot of sort of 50s, 60s small apartments with very narrow doors.
Yeah.
Which we do cater for. And yeah, I agree. I think retrofit is really tough, and I think for us that's why, you know, at least a good starting point, having a product that lasts 20. I mean, the stainless steel hot water tank is great because, you know, it'll be there till 2050. It'll be, so make sure it's going to be interoperable with whatever comes on the way.
I think what your point earlier on about when Alex was talking about Fabric First and all the work that you could do. I mean, we had Bioregional one last week, and effectively they produce this guide that if you had an Edwardian terrace house, it's going to effectively cost you 100 grand to retrofit it to the standards to get to like effectively net zero, which clearly is a ludicrous amount of money to whereas what you're saying is, and what you're doing is a bit like what Joe Alsop and Nathan Gambling is saying. It's like become sort of heat pump ready, you retrofit in stages, and you know your tank currently works with a gas boiler, and at some point then that will go and it'll be replaced, and I think it's much more manageable, and it's good that people are looking at things in different stages. Yes, if you have the means and it's a new build, then you can create something that is going to be zero builds or zero carbon effectively. But from a retro perspective, where 80% of us live in old houses, it's got to be done in stages.
Yeah, and do you know what's we've observed, which we find interesting about retrofit, is, you know, if you're living in a home, you think, I'm going to be there for 20 years, or shall I build a new passive house?
Yeah.
Well, the embodied carbon of a house is like, I think it's like the equivalent of building a new house in the UK. I mean, admittedly, that's with bricks and mortar, and you can get into all sorts of conversations about straw and other materials, but it's the equivalent of running an electric heating system for like 60 years. And so embodied carbon is like a big frontier that it's a big elephant in the room, it feels.
I think and Simon probably knows this, it is coming to the construction industry. They are starting to feel a little bit of the pinch, but not a lot. And I think back to really why one of the things that we got really attracted by on Mixergy was absolutely a point you make about we felt like it was absolutely a sort of a great no regrets first stepping stone for an end user who's looking to become more energy efficiency in their home and ultimately get themselves on a path to net zero. There were some really fantastic trial results that Mixergy had undertaken with a local authority, where it was really just maximise the loft insulation, stick some solar PV onto the roofs, and put a Mixergy tank in, and that sort of combination of measures, which was only on average about 15k per property, took all those properties up to EPC bands, which actually for both social landlords but also private landlords, as and when regulation starts to nibble at them, is actually one of the most cost-effective packages that we've seen actually to move properties on that pathway. But to get to EPC A or passive house standard is prohibitive at the moment.
It is. I think on EPCA, ultimately, if you look at grid carbon intensity, when I started on this, back come 2011, 2012, really, grid carbon intensity was around half a kilo of CO2 per kilowatt hour. It's now below 200 grams, which is interesting because system gas boilers are around 220. So we've now crossed a point where even just using a direct electric panel heater, from a carbon perspective, set aside costs, set aside grid capacity and all, is certainly from an emissions perspective now better. And that trend's going to continue, particularly as we see, Hinkley, Sizewell come online for nuclear baseload. But then, there's something like 70 gigawatts of solar planned by 2035. Which is insane considering peak peak demand in winter in the UK is about 40. Wind is going to double again over the next 10 years at least. Although in the Green 10-point plan, they have aspirations to quadruple, but they're also talking about 600,000 heat pumps by 2028. But even if they get halfway towards those aspirations, as the grid decarbonizes, and if the infrastructure is strengthened sufficiently with demand response, it might be that actually, with the right tariffs, direct electric will play a role alongside heat pumps. I think it's going to be a mosaic of solutions, really.
I think we concur. Certainly at Nesta, we concur with that, and I think we're keen to see as many people as possible sort of taking those first steps, on the journey, but recognise that cost is a barrier, and actually sort of quite encouraged by some of the financial institutions and players in the market starting to think now about how they can support their customers in stepping on this journey, and the Mixergy tank being a no regrets first step. But it's a journey we're on for sure, and it's we will not be arriving at this destination for a little while yet, and particularly I think, as you rightly say, Pete, with the challenges actually of the grid infrastructure that we're trying to put and our housing infrastructure, those two antiquated bits of infrastructure that we're trying to put on top a whole lot of modern technology and cleaner technology, and the two don't pair very well apart from a few measures like the Mixergy tank. So, I'd be very happy, and Pete, I don't know if there's anything else you want to add, but I'd be very happy to see if there are any questions from the people online, or to at least allow someone, if there's interest from the audience, to ask a question. But otherwise, I do have another question I want to ask Pete, but I can save it.
That's great. Julian, who was on the line earlier on, he gave a tour. Is that me? Is that feedback coming from me or from? It's weird.
Hang on a second. Sorry.
Yeah, cheers, Pete. Julian, who was on earlier on, he actually gave a virtual tour of his home. He normally has many questions, and he's just dropped off. I mean, from my perspective, and by all means, please ask Pete another question. But it's what's your next Mixergy? What's your next naked energy, or who is your next? You may not say who your next naked energy is, but what type of firm is doing good work currently, in what sector?
Well, I mean, look, actually, we've been really encouraged across our. Sorry, Pete, I'll let you answer that question. We've been really encouraged. Obviously, we're scouring for innovation across those three mission areas I described earlier, and we do recognise that in our education mission, it's much harder to find genuine innovation. In and around the decarbonisation journey, the built environment, there's a lot of innovation, and it's really exciting. And there's probably a home for most of it. Excuse the pun. But the things that we're particularly interested in are, I think a lot of technology is going to go on an efficiency improvements and sort of cost curve reductions, which is exciting, because it's all about improving the payback for technologies and making it sort of hopefully an easier adoption choice for people, and the payback becoming a little bit more compelling. But I think we're also seeing quite a lot we find interesting in sort of actually how do you integrate the benefits of various technologies, because certain things there's symbiotic sort of existence. I mean, sort of Pete talking about their integrated heat pump, a tank and heat pump. There's some inherent benefits by pairing things, and we're starting to see one or two people now starting to think about actually how can you pair up a lot of these technologies, and how can you make basically the home increasingly intelligent, and actually creating opportunity for consumers to actually benefit directly. I mean, this is something that certainly Mixergy enables, is actually putting some pounds and pence in their users' pockets by connecting the tanks into a fleet to actually offer demand response. So how can you, for us, we're super interested in how can we lower the cost of adoption for cleaner, greener technologies, and how can you actually sort of incentivize some of the benefits to flow through to end users, be those tenants, be those homeowners, for actually using these assets in a coordinated way. In terms of specific businesses, I won't say,
No,
but we've looked at some really interesting ones, and sadly we don't have enough cash to back them all. But we're looking at still looking at a couple of hardware businesses, things that are trying to maybe be a sort of even better than a heat pump, and let's see if that comes to pass or not. But also looking at one or two software plays and sort of service plays, because we do recognise that you've got to take a consumer on a journey, and you've also got to give, you know, the options that a consumer has are really bewildering at the moment.
yeah.
So how can you hold the consumer's hand on that journey, and how can we make sure we've got the right data? We're using data in the right way to actually inform us about, you know, where we should be turning up or turning down or coordinating or stopping, you know. But actually, you know, the better use of data in this, because we've got quite a lot of siloed data sets that actually, if you can aggregate and pull together, you actually might, again, help a householder. That's our framing.
Yeah, there's a lot of data companies out. I mean, we're talking about getting on the likes of Homely and My Global Home and people like that, and then how that's linked to finance as well. And you know, so therefore developers can use the tech in order to show that they're building better, lower carbon homes, and then they'll have access to cheaper green finance. There is a question here from John. Can we make John's question the last one? John, did you want to come off mute, or shall I just read it out, or Alex and Pete can read it? It just says
asking about phase change materials.
Yeah.
So interestingly, I spent quite a lot of time exploring phase change materials, and on face value, they look really exciting. Because why do they look exciting? Because if you take water and you raise its temperature by a degree, it stores a kilo of it, or a litre. That's 4.2 kilojoules, 4.2 thousand joules. Phase change material like paraffin, wax, actually everything's a phase change material. Everything melts, or, you know, but a particular class of phase change materials with the right melting point, you can get somewhere around 300,000 joules per kilo at that temperature. So compared to 4,000 joules per kilo for a degree Celsius, that seems like orders of magnitude better. So at face value, you go, wow, phase change material, super exciting. As you get into the detail of it, you start going, So one of the problems with phase change materials is if you take a hot water cylinder, 150 litres, depending on the temperature, because it's not just 1 degree you have to play with, you have 40, 50, 60 degrees. Actually, the equivalent amount of phase change material you need to store as much energy as a 150 litre hot water cylinder, it will occupy a slightly smaller volume, a better volume, because you can make it cuboidal, it's a nicer form factor, but it's going to weigh 100 kilos. And the materials that we've been looking at them, a lot of different materials, tend to come in anywhere around $7 to $15 per kilo. So you've got, 100 kilos, $10, you've got $1,000 at least of material, just the raw material. The other problem with phase change materials is conductivity. So their thermal conductivity is about 0.2 watts per meter Kelvin. So what does that mean? Copper is a very good conductor, right? So copper is around 400 watts per meter Kelvin. Plastic is about 0.03. Stainless steel is not a very good conductor as a metal. It's quite a poor conductor. It's about 10. So copper 300, stainless 10, phase change material 0.2. So getting heat in and out of phase change materials in its solid form, really problematic. Even in its liquid form, it's a viscous treacle. So you don't get good convection. So it's very, very poor. So what you then have to end up having is a very convoluted arrangement of channels to get lots of surface area. So you've got a small thermal path. That material itself is, typically a metallic material of some sort. So now you've got $1,000 of phase change material. You then add a lot of cost of a very convoluted labyrinth of other materials, or you have to have like a stack of heat exchanger plates with this stuff injected in between. It gets so and at the end of the day, you're looking at something around 0.1 kilowatt hours per kilo, or 300 kilojoules per kilo. So it's tough. And so what we actually think that there's more to go with, thermal store topologies, and I won't go into too much detail, which can get you basically as far as a phase change material based solution, with a lot less cost, and crucially a lot less mass to deal with in distribution and installation. And so it's funny. There's a material scientist who we've been collaborating with, and I'm constantly every few weeks I'll call. Okay, but give me a 5 kWh per kilo material. Come on, I've talked there about physical phase change. There are chemical phase change materials. If you think about petrol, I think petrol's about. Forgive me, I could be aware. I think petrol's something like 10 kWh per kilo equivalent, as compared to 0.1. With wax melting and solidifying, right? So, if you get, okay, burning petrol is not great, but if that was a reversible chemical reaction, and you could fit it somehow conveniently into something, and it's exothermic, endothermic, and you could, there's a way maybe, and there are some classes of chemical phase change processes which look interesting, but various reasons not yet practical.
If you were sitting on the board of Nesta and you were writing out the checks, then you wouldn't be writing out a check to anyone that's going to be looking at phase change.
Wouldn't be for me to. I'm not in the VC game. I couldn't possibly comment.
I mean, maybe replacing a hot water tank for a tank of petrol in your airing cupboard, I think we would probably say no to.
Yeah.
I think, yeah,
doesn't quite stack up. But guys, thank you very much indeed. That hour actually really sort of flew by. So I appreciate that. It was a really interesting chat, a lot to cover. Glad Mixergy are on a really good growth path and doing a lot of good work. And Alex, thank you for asking some really cool, interesting questions. And enjoy your trip to Portugal, Pete. I know it's a work one.
Yeah, it is. I keep having to remind people it is work.
Yeah.
Not just going to Portugal.
No, of course. You haven't got the golf bag put down by your feet. But no, have a good trip. Really appreciate your time. Alex, thank you very much indeed for arranging. And I'll see everyone soon. Cheers, guys.
Thank you, Simon. Thank you, Pete.
Bye-bye.